Hello, today I want to present our research developing the key attributes for product matching based on the item's image tag comparison. So, our motivation in this research based on some problems and limitation in e-commerce business. From one side, the quantity of sellers and customers has a rapid growth, and sellers manipulate by product description information. From another side, people spend a lot of time in order to get enough information about different items and try to find similar goods in different marketplaces. So, in our work, we try to improve the consumer experience and approaches of item matching, and we hope to improve the search process on the web marketplaces. On the slide, you can see some examples of item representation. So you can see sneakers of Adidas from eBay side, and you can see these images are very similar, but not all. So we try to find answer on this question: are these goods on the images similar or not? Based on the text information of these items. These problems actually not only eBay marketplace but also for Amazon, AliExpress, etc. So the main goal of this research is present the idea of image matching combined with matching textual descriptions of items. The general schema of item processing is next. So on the first stage we chose an electronic trading platform and collect images and description of goods. After this, we inspect the raw data, clean and organize the dataset, and collect pairwise comparison of item images. After this, we build the set of items with similar images, and on the final stage, we create the core of tags based on item description. This is an example of item in our dataset, so you can see image and a list of tags for this image. You can see that this list does not contain not only words, but also different numbers, size, words in uppercase and lowercase, different symbols, years, etc. So we need to clean our information. After first stage, we extract set of tags and delete all punctuation, and also remove tags with lengths less than 3 symbols and stop words, and generate new tags from long description. For example, casual shoes divide into two tags, casual and shoes, or fitness studio and training divided into 3 tags, fitness studio training. Remove digits and calculate frequency of tags. After this, we delete repeating tags and receive final core of tags with their frequency. On this slide, we present information about our dataset. So, we divide all our collection into 2 datasets. The first dataset contains only information about white sneakers. These sneakers are very similar. And the second dataset contains different shoes. Based on the first dataset, we receive tag core. We present also this tag core on the slide, and we compare each image from second dataset with this tag core and try to define these images are similar or not. On this graph, you can see information about number of tags after different stages of our experiments. So on the initial number of tags is over 2000 tags, and after all stages we receive over 250 tags, so it's a very good. And on the last table we present information about all tags after cleaning, and these two columns with different threshold value. So we did not research threshold value, information about threshold value in our experiments, but it's really interesting and it's separate task for future work. So it's a work example. We have 4 examples, and the first shoes are very similar to our tag core. We receive similar score is 0.8, and the next values are very similar, is 0.6 and 0.5, so it's not similar items for our first data set. Yes, and we present also information about experiments similar of similar metric in between first data set and tag core, and second data set and tag core. So the first graph shows that items in our first data set are very similar, and it's a correct, yes. And the next graph shows that we have very different items, very different shoes. It is also correct situation for our second data set. And this is some example from our results. So we present some items, similar items, and they are similar metrics, and you can see that these shoes are really similar. Yes, they have a white color and a similar score, more than 80%. And for the evaluation, we use precision, recall, and accuracy metrics. So the accuracy 74%, precision 88%, and recall 89%. So this is a very good result, I think. So the conclusion and future work. Our algorithm is working good for this data set, and the results are really good, but we have 2 open questions. So the first, we need to analyze threshold value for our tag core generation, and we need to adaptate this threshold value for different items from different marketplace categories, for example foods or clothes or TV sets or smartphones, etc. And of course for future we need to collect information not from only from eBay, but also from different marketplaces, and we need to add more and more data for our data sets, for our experiments. So this is our future work. Thank you for your attention. Bye.